This week, we're going to be focusing on the crux of the matter, on ITL and CTL files, which are the key elements which allow the phones to trust the call manager, and understanding and managing them is the most important part of performing an upgrade or changes to your call manager, because a lot of the issues that can be caused by these files can be avoided. However, if you do find you have issues, there are ways around managing them, deleting them, and getting the trust working again, and we'll be covering all that. So I'm just going to do the introduction. So as if you were here last week, this will be familiar to you, but the session is being recorded again. So please do ask sales at UnifiedFX if you want a copy of this sent to you. And I probably anticipate a bit more questioning this time around, because it's quite a topical subject that we're going to be covering today. So when you're submitting questions, please submit them to the Q&A box, and please submit them to all panelists, because there's one or two of us on the session today, and while one of the presenters are talking, the other people could be answering questions. However, as I said last week, if there's any left at the end, we will take time, and we've got a little session to review them all and cover them all off. I'll be brief with this introduction, because by now you should know these people. And yet, once again, we've got our resident Cisco security expert with us. I can say resident as he joined us last time, and hopefully will be joining us next time, Akhil Beal. Akhil is recognized within Cisco as a specialist in this subject, and in fact has written a book called Securing Cisco IP Telephony Networks. As I said last week, we read this book and then we decided to build these features into PhoneView based on the back of what we're reading there. It's a very interesting book, and we can highly recommend it. And our second speaker today will be Stephen Welsh, our CTO, and the original author of PhoneView, our product which will help you manage ITL and CTL files. Okay. So the agenda for today, again, similar format, split into two. Akhil will be taking us into a journey of education around the understanding of PKI in general, and explaining what CTL files and ITL files actually are. Then we'll be handing over to Stephen Welsh, who will be using his everyday experience helping many large companies with these type of issues and resolving them, and giving you hints and tips about what to look for when you're going through your normal daily operations or upgrades to avoid any problems with these type of files. And at the end, we'll be doing a short demo again on how to delete them and how to rectify them if that is required. Okay, so I'm just about to hand over to Akhil to take you on the rest of your journey. And just once again, thank you all for coming back and joining with us again in this session.
Thank you, Andrew. Morning, everyone. Evening, everyone. Good day, wherever you are based geographically. Welcome to this session. So as Andrew introduced myself and Stephen, so I'll be steering the first part of the session, followed by Stephen steering the second half of the session, along with a demo of PhoneView, where it comes in handy to manage and troubleshoot regarding ITL and CTL issues. With that said, let's get started. So here's a quick introduction to Cisco UCPKI, our public key infrastructure. So what exactly that is, and how Cisco is leveraging the public key infrastructure in its UC paradigm. So public key infrastructure is nothing new. It's been there for a while, and it's there to stay. So essentially what it is certificate-based authentication, and there is a root to every trust which acts as a transition of trust between two or more entities. So it's a third-party entity which brings an element of trust amongst or between, depends upon there are many or one-on-one, two entities within a system. So for example, if A has to talk to C, how does A know who C is, and if A can or should trust C? So there is a B in between. So A talks to B, A trusts B implicitly, and that B in this case becomes the third party entity, which is the root, or better known as the root CA. Now there can be a hierarchy to that as well, which would be a root CA and an intermediary CA, and then that is issuing identity or the local certificates to all the entities in the environment or the setup. With that said, so A says, B, can I trust C? B says yes. C's public key seems to match what I have in the database, so you can talk to C, no issues. A reaches out to C, and at that point in time, C says, A, I don't know you directly, so let me talk to my trust point, or my trust introducer in this case, and it goes back to B, and the story continues. So once B has said to A and to C that you're good to go, A and C establish communication, and that's exactly what happens in a Cisco UC environment when an endpoint talks to a communications manager. When phone A wants to talk to phone B, there is implicitly no trust relationship directly between these two, but the implicit trust relationship lies with the trust point, which is this UCM. So how that is happening in the background is every entity is using asymmetric encryption in this case. That is, there is a public key and a private key. So every entity has a public key for the remote endpoint. So say a phone would have a public key of the call manager, by which it would encrypt data and send it to call manager. Call manager would decrypt it using its private key. And similarly, when the call manager has to send signaling to a phone, an encrypted or a secure phone, that is a CAPF enabled phone, it will encrypt the data using the phone's public key, send it to the phone, and the phone will decrypt using its private key. So essentially, the only element which is exchanged between two or more entities in a PKI environment is the public key. The private key is never exposed. So it is highly secure as compared to a symmetric or a singular key mechanism. Now, what Cisco does leverage is the X.509 version 3 standard for PKI, that is for the certificates. So it's a well-established standard, and almost every certificate you can find in your browser store or otherwise would confer to this standard. So Cisco is also using standards-based encryption using asymmetric algorithm, and has various elements to it, such as the signaling uses AES 128 and SHA. So SHA is for hashing and AES for actual encryption of the packet, so on and so forth. So with a quick introduction to what PKI is all about, let's understand how Cisco UC is leveraging it. So what Cisco UC is, it's not a singular PKI system, but it's an element, or it's a hierarchy, it's an organization of PKI. So if I get a phone from factory and right out of the box, the phone would not have encryption enabled by default. However, the phone does have certificates which can help enable encryption in no time. Now what that implies is, since the phone has some certificates built in it, which we'll see later during the presentation, are the manufacturing installed certificates, then how can phone trust an application, whether that application is the communications manager or its Unity connection or its cups? So the phone really doesn't know to whom it is talking to, and that is pretty much solved by making a hierarchy, that is, making the applications also have Cisco manufacturing installed certificates on them. So the moment you're installing, say, Communications Manager or Unity Connection, what also goes hand in hand are certificates. So the first time you would open up a browser and try to browse to a CUCM web page, it is going to redirect you to a secure web page from 8080 to 8443. And that is the Tomcat certificate, and that is built in already in the call manager. You didn't have to do anything at all except install the application and get it running. Similarly, there are certain certificates which are by default there. However, they do need to be activated or signed by a third party or even self-signed certificates, they need to be leveraged in a certain manner or as per the organization's requirements, security requirements or security policy, such that they can be leveraged to the benefit of the organization. So what we do have is the CUCM. In fact, any and all UC applications in Cisco paradigm, they all have self-signed certificates. They have a built-in root CA, which is the Cisco manufacturing CA, which assigns certificates to different trust stores, such as Tomcat, such as IPsec, TVS, CATF, and so on. So there are multiple trust stores. Each has its own specific function. And what you can also have is, in addition to self-signed certificates, if your organization demands that the certificate should be signed by a central authority, that is also possible. Almost every certificate in Communication Manager is there to be signed by a third party, such as VeriSign or Tuore or GeoTrust or any approved CA, even Microsoft. Now, as I said earlier, there are manufacturing installed certificates, better known as MICs. That's the abbreviation for that, on IP phones, which are by default signed by Cisco CA, that is Cisco Manufacturing CA, which are good for over 20 years. And these are burned just like MAC address would be into the phone's flash. You just cannot replace them. You cannot renew them. You cannot play with them, essentially. So they are there to stay. They are there once the lifetime is over, it's over. But then 20 years is a good lifetime. Now, there are second category of certificates, which are locally significant certificates, better known as LSC. So LSC is something which is installed on a phone when the phone is secured using the Certificate Authority Proxy function, or known as CATF. So it is something which is not by default there, but you can enable it. And the difference is that MIC is manufacturing signed. LSC would be something which is signed by an e-token and a CTL client from Call Manager. E-token is a piece of hardware. There are USB keys. You need at least 2 of them. So essentially, where we are getting at is Cisco UCPKI is not a single entity. It's an entity which needs to be brought together for greater security. Cisco has done that it hasn't kept anything at a default. So once it's compromised in one organization, the other organization also faces the danger of being compromised or exploited. So with that said, it's a hierarchy. It's an organization in itself, and there are root CAs, there are intermediary CAs. You can pretty much have third-party intermediary CAs signing the CUCM or CUC certificates. So essentially, you need to bring together the different components, right, from endpoints to call control to voice messaging to instant messaging and so on and so forth. You need to bring them together in order to have the whole PKI system working in line. Again, what is important here to stress is every organization has different security requirements and different security policy. So this may need to be fine-tuned with that organization's security policy as to how many types of certificates do we really want to have third-party signed or self-signed. Some organizations have a flat rule, no third-party signed certificates. We can live with self-signed, but then there are financial organizations, there are banking institutions which simply cannot tolerate self-signed certificates. It's against their policies. And also, it may impact some government regulations and laws. So all in all, what entails is they want to have everything third-party signed, and Cisco does empower you to have third-party signed certificates on your UC servers, whether that is, again, call control, communication manager, voice messaging, Unity connection, or Unity, and so on and so forth. With that understanding, let's dwell a bit deeper into MIC, which is the manufacturing install certificate. So this is the primary and built-in mechanism to have a Cisco IP phone trust only another Cisco manufacturing installed signed application or device. So if an IP phone using MIC has to establish a secure connection to, say, Call Manager, then obviously Call Manager should have the public key for the IP phone. And on the first go, the phone will ask, do you really have the same signed authorities certificate so that I can even authenticate against you? And yes, the answer is pretty much yes, because the same CA signed call managers' self-signed certificates or built-in certificates, as well as signed the phone's built-in certificate. So pretty much they are at the same level. They can go and they can establish a secure connection once CAPF is enabled and we use MIC as a basis. So what phones do need to do is, as it goes in a PKI hierarchy, you do need to submit your certificates, that is the public key, only the public key, to the CUCM, and they try to register. CUCM, again, since they already have certificates which were signed by Cisco's manufacturing CA, the same as in the case of phone, they verify the submitted certificate, and since the signature matches what is in their database, that is call manager's database, the phone is allowed to register. Now, if a rogue phone or a third-party phone without MIC or say a tampered MIC certificate, if someone is trying to emulate a phone or as a soft phone on a PC, with emulating it as a phone in a voice VLAN or hopping the voice VLAN, then again, that phone would not come up because the signature for that modified certificate would probably never match what's out there in the call manager. So right then and there, you have killed a rogue phone. So there is another type of certificate as discussed previously, which is the locally significant certificate. Now, I would like to make a point here. Locally significant certificates are a function of CAPF, and the root for locally significant certificate or LSC is CAPF. So essentially, even if you sign CAPF certificates by a third-party certificate, what is going to happen is the phone certificate is always going to talk to call manager. It is never going to talk to remote CA. And that is going to change from version 10 onwards of call manager. But anyhow, all in all, what this means is that you do have power to overrule the built-in certificates and overrule them with a locally significant certificate which is unique to each endpoint, which is not a common certificate like a Cisco signed certificate, has a common name and so on and so forth. And LSC is very, very specific to an endpoint because it only gets created when you apply a secure phone profile to a phone, and then the phone downloads a certificate from call manager. So again, LSC enabled encryption is more secure compared to a MIC enabled encryption. Just keep that in mind in case your organization requires a least privilege or a least trust policy. If it follows it, then you should be ideally going with LSC and not MIC. So again, what happens in the background is once the CAPF service is enabled and the CTL service is enabled on every member of the cluster, so CAPF is just on the publisher, CTL is on every member of the cluster, the e-tokens sign the certificates on all the members of the cluster, and consecutively, the IP phone with a secure profile exchanges certificate with the call manager. So call manager says, okay, I have your MAC address provisioned in me, so here is your certificate with your MAC address. And once the phone gets that certificate, and again, it's only during that time the phone is pretty much vulnerable because that first communication is unsecure. So ideally, if any enrollment has to be done, it should be done in an enclosed or a private environment, and then the phones can be shipped out to the sites. So that's again a leading practice. So once the phone has an LSC certificate, every time it has to establish a call with the call manager. The moment you go off on the phone, it's going to send the packets encrypted with call manager's public key. Call manager will decrypt it and send a reply back encrypted with phone's public key, and the phone would be able to decrypt it because it has the right set of certificates. So as it goes, the phone and the call manager now have established a trust relationship, and this is a transient trust relationship. That is, phone A to call manager to phone B is always via call manager because phone A and B directly do not know each other at all. The signaling always stays on the call manager, and so thus the trust point is the call manager. Now, once phone A has negotiated with call manager, B has negotiated with call manager, they can pretty much go for open media channel and establish SRTP using certificates. And the certificates are good for that call. I mean, that's for that session, and they cannot be replayed unless someone is able to capture and decrypt it. So it's a pretty secure mechanism right there. So with that said, there are two types of security files. Now we need to understand. One has been there for a longer period than the other one. So the one I'm talking about is the certificate trust list. So this is the file which gets downloaded on a phone the moment a phone tries to register with a call manager. And this file is pretty much the crux of what you just did with, say, the CTL client and the USB-E tokens. So it's a compilation of all the members in the cluster, whether that's a firewall or a TFTP server or a call processing server or an MOH server, irrespective of the role of the server. Every server's details are captured in the file, the right signatures are in the file, and that file is downloaded on the IP phone when the phone tries to register with the call manager. Now what happens then is, every time the phone tries to contact a call manager, it will not, I repeat, it will not trust anything beyond what is there in the CTL. So say you have a 10-member cluster, all those 10 IP addresses and host names will be in that file, and phone will not trust anything beyond those 10 servers. So if you add another server to the to the cluster, you have to rerun the CTL client again to make sure that the CTL file is updated, or the phone is simply not going to trust or even talk to that server because it's not part of the CTL file. So what CTL file is, it's a function of CAPF. Again, CAPF is the root for locally significant certificate, and CTL client creates the certificate trust list file, which is downloaded on the endpoint. It is stored in the TFTP root directory. So for troubleshooting, if you want to access it, you can even do from the CLI. And then what is out there already is now ITL with the introduction of Call Manager 8.x. The first version of Call Manager, which came along with the concept of security by default, was 8.0. CTL has been there for ages. It has been there since Call Manager 3.x, and it's still there to stay. ITL is not going to replace it at all because the function of these two files is different. Even though ITL can be seen as a smaller version or a leaner version of CTL, but that does not make ITL a CTL. CTL is required, and CAPF is still required for secure signaling and secure media. So if you want to enable TLS for signaling, whether that's skinny or SIP, or you also want to enable SRTP for media, you need to have CAPF running, you need to have the CTL file, and you can do it either with a MIC or an LSC, doesn't matter, but then CTL has its own place in Cisco UCPKI. So ITL, again, this is a very interesting concept around which the whole series has been built. So as was also discussed in the previous session, the first session, ITL is something which Cisco introduced because when you take a phone out of the box and just connect it to a call manager or register to the call manager does not know about the phone doesn't know about the call manager or whether it should be trusting it. So at that point of time, what does come in handy is something which is secure by default, and at that point in time, the phone, when you install the call manager cluster from 8.0 onwards, that is higher releases, the ITL file already got built, it was there, it is just a matter of installing the phone, and then once the phone is configured in the call manager, the phone registers with it, it downloads that ITL file as a process of downloading the first config and firmware and the ring list and other files. So then, from next time onwards, again, it is similar, it is synonymous to CTL but not CTL. The phone is only going to trust what is there in the ITL file. It is not going to trust anything beyond it. So again, ITL is a leaner version of CTL. It is not CTL. Why? Because ITL is created using built-in soft tokens. And the major difference is ITL is there for security by default. That is, the endpoint should be able to trust call manager and vice versa. However, CTL is there more so to enable call manager and the endpoint to do either authenticated signaling or encrypted signaling and media. And ITL cannot do that, either of those. So ITL is security by default. CTL is a result of CAPF and CTL client enablement, but both have similar yet different functions. The last point I would like to cover here is ITL format. You can look at the format of the files. You can log into the CLI using SSH of a call manager server. And if you already have CAPF enabled and running, that is, you have security enabled, what you can do is you can issue the command show ITL, and that would show you the ITL file and even tell you which e-tokens or soft e-tokens were used to sign the file. And when you do the same thing for CTL, that is, you issue the command so shows CTL, that is going to show the CTL file to you, and you can compare. The format is exactly the same. It is just the content and the way the services work in the background that these two files can be differentiated, or these two services are differentiated. So with that, I would like to pass on the ball to Stephen, and he'll steer you through the rest of the session for detecting ITL issues, troubleshooting, and a demo of PhoneView for the same.
Thanks very much, Akhil. That was some great information, really appreciated. So as Akhil has explained, the PKI infrastructure that's used within Cisco Communications Manager, from an endpoint perspective, the two main considerations are ITL and CTL files. So, they really link to the trust level of the nodes within the cluster. Now, CTL files have obviously been around for a while, but that's always been an optional element that can be enabled according to the organization's policy. But obviously with, as referred to in the last session, with the impact of security by default, that default position of the cluster from version 8 onwards is of a basic security standpoint. And the ITL files, the effective implementation of that from an endpoint perspective. So actually a lot of the ways of managing ITL files is actually similar, effectively the same as CTL files. Now, one of the things we talked about in the last session was the recommendation to actually move from the kind of default mechanism of ITL files to CTL files. And one of the reasons why you'd want to do that is, unfortunately, in the real world, that we do sometimes see the ITL file can get out of sync. That's fundamentally because it's self-signed certificates, those soft tokens, that sign those. So certain communication manager changes can trigger new ITL files to be issued for the phones to use. But if anything goes wrong with that synchronization, there's lots of reasons why that can happen on occasion, then you may have a number of devices. It might even be a very small number, 1% or less in some occasions, that basically their ITL file is out of sync. So then it becomes important to understand if you do have any files out of sync. But as I say, applying these kind of strategies to CTL files also is relevant, because the kind of procedure to remove them is effectively the same. And we'll do a bit of that in the demo. So one of the key things that we added to PhoneView is the ability to detect ITL issues. We've actually got two ways to do that, and we've listed out what the key kind of parts to that are. So there's a concept called an ITL status. This is something that we gather from the phone, and we interpret it and we present it through, and based on that particular status message, we can find out if the phone is out of sync effectively. The message there that's listed, trust list update failed, that represents the fact that the ITL file has attempted to update, because every time the phone resets, it will try to download a new ITL file. But it's like a catch-22, and this is how it should be. It will only take an ITL file from a trusted source. So if you make a change on all your nodes from the perspective of the phone, and it no longer trusts any of the nodes on your system, it can't take a new ITL file. So it's those kind of scenarios that can happen on occasion, which may cause you to see such messages such as trust list update failed. And that for us is one of our key detection mechanisms to find out if you have an issue. And the thing is, this is really important because it's the percentage of phones that get affected can be really small. But the knock-on effect of the phone no longer trusting your call manager may not be directly obvious. You know, the phone still registers, you can still make phone calls, but there's some subtle changes that will no longer work. Phone firmware upgrades, things like that. So that's one of the key mechanisms we have. It indicates that the phone doesn't trust the TFTP server because it's not downloading the new certificate, the ITL file from it. It does require the phone's web server to be enabled, but actually, ironically, it does not require the phone to be registered. We do find, it's quite rare, but we do find on occasion that the phone might get out of sync and have an ITL update issue and also be offline. It's quite rare, but on occasions when that has happened, we can still kind of detect the phones with an issue, and we even have ways to resolve that too. Then the second metric that we kind of use and information that we can gather, and this is really typically part of the kind of scanning operation, which is a relatively new feature that we've added to our product because it can gather all this data, like in a single transaction. So the other piece of that data gathering is what we call TVS status. Now, the two types of certificate primarily that sit within the ITL file are the TFTP server and the TVS services. Now, there can be more than one of each, obviously. Now, the ITL status will pick up the fact that the TFTP server certificate is not trusted, but there are some rare situations where the TFTP server may be trusted, so, you know, the ITL status is fine, but it might be a case that the TVS service isn't trusted. Now, you know, typically restarting the TFTP and TVS services will resolve that, but even after all that, if you want to make sure that everything's kind of working and correct, that's why we've added things like the TVS status. So in this case, the way that it actually works is it does require the phone to be registered, that's a prerequisite, but it doesn't touch the phone's web server. So, you know, even if you have some of the default settings that come along with security by default, where the web server is now turned off, and it is obviously a good practice to follow, it's still possible to find and detect ITL issues using that mechanism. So, you know, it's as good as we could make it in terms of covering all bases for all situations when you may have some ITL files that are out of sync on your endpoints. So in terms of resolving any issues that may happen, as I kind of indicated a moment ago, the first course of action is typically, you know, you have to understand the problem, obviously, but, you know, these are the things that you typically have to do. It's quite common that you might have to restart your TFTP and or TVS service, because when a self-signed certificate changes because of some kind of node change, you know, that's things like the name of the server, you know, the NTP server, you know, kind of things like that. There's, you know, 5 or 6 kind of parameters that can affect and are part of the self-signed certificate. So if one of them changes, it'll cause that to be regenerated. And if that does get regenerated, one of the nodes within the communications manager system, it will actually have to kind of get that information through to the TFTP service, the TVS service, and then down to the phone. And in some occasions, you have to obviously restart the TFTP service to make that happen. There have been enhancements, you know, since 8.0 to the latest versions, you know, in 8.6, etc., and onwards, where some of these mechanisms are kind of done automatically, or you're actually warned better in the communications manager interface if you have to restart a service, etc. Because if you didn't do it, you might actually have an ITL problem, and the easy fix is just restart a service rather than having to go around and delete all the ITL files, which can be quite painful in some situations. That's the first port of call. Now, the thing about ITL files is they're actually really simple to remove. You know, it's just a few key presses on the phone. But the way we can, or one of the reasons why we put our product together, is if you think about it, Communications Manager's database has a lot of phone information. Probably we kind of class about 80% of the information that a phone contains within it is held in the database within the cluster. However, there are still approximately 20% of a phone's configuration, which is local to the handset. Things like the background image, the TFTP setting, if that's manually set, you know, a whole range of things. They're kind of less relevant in some situations, but you do have to interact with the phone to access them or change them. And ITL and CTL files fall in that category. They're, for the reason of security, they're local to the handset, and it's for the handset to trust the cluster, obviously. So that's why they only reside there. And actually, they should only really be managed at the endpoint as well. But the thing about this is, because especially with ITL files and security by default, if you do get some files out of sync and you've restarted your TFTP and TVS services and it's not resolved the issue for you, then actually having the ability to detect ITL issues can save you a whole bunch of hassle, because it can obviously minimize end user disruption. You don't have to delete the ITL or maybe CTL file from every single phone on your system. So if you've got 10,000 users on a cluster, that's quite a big disruption. And if you've got different time zones, that could be quite difficult to manage, because it might be a 24/7 operation at some level. So it makes it proactive and efficient in terms of resolving issues, if the TBS and TFTP services don't fix it for you. And the kind of last case scenario, but this is quite rare, is a factory reset. So if, removing the ITL file, obviously you'd want to do it remotely using PhoneView and as efficiently as possible. Doesn't work for you, then you might have to do a factory reset. However, as part of the scanning operation and the analysis that PhoneView does in terms of a wide range of settings and profiles on the handsets, we actually have a remediation capability, which I'll show you a little bit of in the demo, and that actually pinpoints any phones which it's not possible to fix remotely. It's quite rare when that happens, mostly because the phone settings are locked, but we kind of summarize that data and kind of tell you where they are. So that's really it in terms of resolving issues. The one last point is a lot of people use the pre-UCM8 rollback setting. It's an enterprise parameter. And what that does is it effectively tells the phone not to, or to kind of trust any ITL file. Effectively, it's kind of like deleting the ITL file. But in effect, even though the phone will follow that instruction, and effectively allows it to move from one cluster to another and trust a new node, etc., and download a new ITL file. The problem is, if the phone is already out of sync with its ITL file, it won't actually trust that instruction to roll back, and remove its certificate effectively. So the problem with that is, it may give you a false sense of security. So you might think, I'm going to do an upgrade, I'm going to use the pre-UCM rollback setting because I know all my phones are going to remove the ITL file. But the problem is, if you have some phones, even just a couple of percent, that are out of sync, it will have no effect on those phones because they won't trust that configuration update. It's one of the things that comes down from Call Manager and the phone's configuration file. So you have to kind of be aware it might give you a false sense of security, and as we described last week, it's something that's really a transient setting for upgrades. So it's certainly obvious, but you need to be careful you don't put 100% faith from a problem resolution perspective. So in terms of endpoint security in general and managing that within the cluster, there's a few points I'd like to make out. In particular, some kind of unique situations such as centralized TFTP. So if you've got multiple clusters and you're using a centralized TFTP environment, which is convenient in terms of you can have all your phones with a kind of similar DHCP configuration, etc. You have to be aware that you have to do a bulk certificate export, so you can get a kind of shared view of all the certificates between the different clusters. So that's one step that sometimes people aren't fully aware of. Another key element, because of the mechanics of security by default and the ITL files, you cannot mix pre-Call Manager 8 clusters, so Call Manager 7 and earlier, with any system that's running version 8 or above. If you've got a mixture of versions, then the only way to have certificates properly trusted, you can't use ITL files either. You actually have to deploy CTL files across all the nodes within the cluster. So that's just one of those rare kind of use cases that you need to be aware of from a design perspective. If you're doing major upgrades and changes, something you may have to do, especially if you deploy CTL files and you're moving from one cluster to another and you haven't shared the kind of root certificates, those USB keys, if you haven't migrated them across. We've seen projects where the responsibility of a cluster has moved from one organization to another, and that piece of information, the USB tokens, is not translated with it. So it's effectively the cluster might be moving in the configuration information, but you know, the security certificates are not. So in that kind of situation, you will actually have to delete all the CTL files. You want to make sure that's as fast and as efficient a process as possible. Endpoint scan, we'll show you a little bit of that, and obviously covered it a little bit last week as well. But the scan's more than just data gathering, because it actually analyzes information that comes back, and that's the seed of what the report is built from. Also be aware that from an endpoint perspective, there's authentication and encryption, which is driven from the CTL file, which is really the basis of you know, the Cisco PKI that ITL has been building upon in his explanation. And these features here, we can actually gather data on the kind of security mode of the phone as well. So you get an understanding of the endpoint security configuration. So that's something that PhoneView also gathers. And it's one of the kind of messages is you didn't previously have to worry before Communications Manager version 8 about ITL or CTL files unless it was a specific, you know, requirement of the customer from an encryption security perspective. But because of Communications Manager version 8 and above, you do need to consider these elements within any upgrade. And we've seen some occasions, even with phone firmware upgrades, that I've seen, you know, it causes issues because a phone won't upgrade if the ITL file's out of sync. So you can end up with phones in old versions and, you know, things like Drive to 9, which is a big incentive at the moment, making sure all your phone firmware is upgraded consistently and accurately, you know, as you move up to that major version. That's quite an important factor. So that's all falls into endpoint security. So the last piece to talk about before I jump into the demo, and we're running a little bit longer than last session, so I'll keep the demo quite short, is the kind of report. We touched on that last week, but basically the book is the kind of inspiration for the report, and we tied the book quite carefully into the report to make sure that if you need to delve deeper, then that's led in. So really it's about gathering the data, presenting it in a concise manner in the report, and then delving deep if need be in terms of full text. So that leads us on to the demo. If you just give me a second, I'm just going to swap over and share my machine. Okay, so I'm currently running PhoneView. I've got it all opened up and ready, and it's, you know, our product's kind of interesting with what you can do literally anything with any number of phones. But where do you start? Because it's actually quite simple in terms of its layout. And one of the kind of common tasks, as I say, is deleting ITL and CTL files. But you know, there's a lot of things in here, so I'll kind of take you through them very briefly. One thing that I've opened up, which we don't normally show very often, is we actually have embedded real-time information. And this is good if you're doing phone resets and upgrades. And because I'm going to do a small reset of the phones in a moment, I've opened this up. So you can add a whole bunch of statistics in here, anything from the real-time monitoring tool performance statistics. So I just get added in here the registered hardware phones. So you can see I've got 2 nodes, a red line, a green line, and I can see how many phones are registered against each node. Now, what I'm going to do first is scan the cluster. So we'll open up the scan window, and we'll just go and choose all the devices. Now, although I've described the TVS status, I'm not going to run that particular session at the moment, so we're just going to get the ITL status. So we click Next, just a small system that's just running through, gathering the details on those devices. And it's quite a lot of data that we gather, and some of it's quite specific in terms of its analysis as well. And there we go. We have the results of that exercise. We can see here that pretty much everything's got a green light. We've obviously got some parameters that might need looking at in terms of phone hardening. Now, I actually haven't broken any phones on this occasion, but if you have any phones that had an issue in terms of ITL status and TVS status, you would get a red flag in here. So we click OK, and that takes us to generate the report. I've actually got it open already. So this is the kind of output that you get. I can show you that in a little bit more detail, maybe at the end if we get some time. But what we'll do is kind of move into actually how you delete the ITL files. Now, because I've gathered all that data, And one of the key things that we get is the ITL status. So if I go to our Data Explorer on the left-hand side, this breaks down automatically all the different ITL status messages that we received. Now, we don't have any errors, but if you imagine that there was an entry here that said trust list update failed, I can click against that entry, and the visible list of phones is instantly filtered to just those devices. So if you had an ITL issue and it was just these two phones, for example, it's really simple. You just go and select them and then perform the ITL deletion sequence. But what I'm going to do is I've got 4 phones here, which are quite good for demos, so I'm going to just filter down to the 7961 model. And let me just zoom in a little bit so you can see them a bit better. And what I'm going to do is if I right-click, I'm just going to enable some automatic screenshots so we can see them updating. Just to kind of prove that out, if I select those phones and I just press some buttons on the keypad here, you can see I've got direct control of the chosen endpoints in front of me. Now, the procedure I'm going to follow here, and this is really for simplicity and consistency, is I'm going to do a hard reset first, okay? So if I do a hard reset, then those phones are going to reboot. Now, if I go down to the bottom here, and what we should see is the red line and the green line changing. So we can see that there's a number of devices on one node. Looks like there might be 3 on one and 1 on the other. So that will reboot. Now this is going to take a minute or so for them to come back up. So we'll kind of wait for those lines to move up. But basically, once those phones come back up, and the reason why we do that is in order to delete an ITL file, you need to make sure that the phone is unlocked. So the settings menu is unlocked. And you also need to make sure you can consistently open, the appropriate page on the phone to navigate to that section. So we've actually got 2 other little buttons here. These are just macros, and these are independent macros. And what that means is, no matter which phone model that you've selected and you're interacting with, PhoneView knows that model, understands it, and translates that request, to unlock the phone into the appropriate key sequence for those devices. So in that particular case, it's going to press the **# sequence to unlock those devices. Now the ITL macro here is a similar thing. It's a pre-built macro that will do the appropriate sequence depending on the model. So it just makes your life easier. So the sequence basically is reset the phones, which I just did there. They're now back on. We can, because obviously I'm doing this as a demo with just a small number of phones, I can show you them visually. But if you were doing this on 5,000, 10,000 phones, that's where the graph at the bottom comes in handy, because they're all back online again. So we can see the phones are all back. Now because I've had a hard reset, they will be in a locked state. So the settings menu will be locked. So if I now click the padlock icon, it will now go through to each of those phones, and if you watch kind of carefully, you can see the little padlock opens up there. Okay, so that's the prerequisite. And if I now go to delete the ITL file, now as you can imagine, it's the exact same procedure, but you would just choose CTL if it was the CTL file. So if I click ITL delete, and if you watch the phones carefully, you'll see that it goes through, navigates to the appropriate page on the phone, presses the kind of sequence to erase it, and you can actually see the phone just reboot there as the ITL file was removed. Again, if you look down at the graph, it's like a soft reset effectively, so the phones are away and then they come back again. Okay, so that looks, just waiting for one more to come back online there. And that should be us. So that's really it in terms of a demo. There's a ton more features I could go into, but fundamentally, scan to get your data. ITL status is a key parameter. You can also use TVS as well. You've got your report here. The one kind of section that's probably worth covering is the one near the end, which is the remediation section. So because of the data that we gather and the analysis of it, we can actually figure out instantly how many phones we can fix remotely, and if you do need to physically visit any phones, how many they are, and we give a spreadsheet out with all the details of where they're located, etc.
PhoneView from UnifiedFX, you may never need to send an engineer to site again. www.unifiedfx.com